So this is what we were, and this is where we were. Okay. Okay. So we got this one more equation from the polynomial just by utilizing one of the constraints. Okay. And then similarly, we take this constraint, this final condition on the trajectory, and we replace every t with the tf. अब इस पे न्यूमेरिकल करेंगे तो फिर आसान हो जाएगा. इसकी जगह कोई 170 degrees. We'll do the same which I showed you here, but I'll let you do it, practice it. ठीक है? Okay, and find the coefficient. And QF will be QF will be here because this is Q at time TF, and then replace T by TF everywhere. And similarly, utilize the final velocity constraint by putting this in this. Okay, and we're not going to utilize this because no constraint has been, no condition on the acceleration has been given, but there might be given in future, and we'll see that. Okay, so now what you have got is you have got these four equations. The unknowns are A's, A0, A1, A2, A3. So group all the unknowns in one vector. Okay, and whatever is left, group it in a separate matrix. ठीक है, देखें अब इस वन को, इस रो को मैं इसके साथ मल्टीप्लाई करूंगा तो I'll get this back. कैसे? 1 will be multiplied by A0, which is there, plus T0 will be multiplied by A1, which is there, plus T0 square will be multiplied by A2, which is there. T0 cube will be multiplied by A3, which is there as well. So इस फॉर्म में लिखने से इक्वेशंस पे फर्क नहीं पड़ा. Just another way of writing these equations. It's a vector and vector form. It's a matrix form. ठीक है? Why we are doing it, I'm telling you next. The reason we are doing it is we want to solve all these equations simultaneously. Okay? क्यों? Solve for what? Solve for A's. Okay? And on the right side, whatever you have is group in one vector. Call it vector B. Call this vector A. And the coefficients that you have grouped into that matrix, call it matrix capital A. Okay. So now how to find A? You will have to multiply both sides with the inverse of matrix A. So that will go to the right side, and the A inverse will be multiplied with B. And once you do that, you will get the values of A. Okay, A's will no more be unknown because this is known. These values are given. T0 is given. TF is given. Everything will be shifted to the right side. We'll multiply the inverse of A with B, and we'll get the exact values of A. And once you plug them in here, then you will get your exact trajectory. And how will we use it? That I'll show you next. But first, I want to do it for this problem. Which one is easiest? Let's say join 2 कर लें. इसकी calculation लंबी हो जाएगी. I have example on the next slide. Let's say initially you were at 0. You want a certain joint to be at 0 degrees. And after some time TF, after 1 second, TF is 1. You want the joint to be at pi. Pi means 3.14 radians. ये radians में है y-axis. Position part है ये given. 0 पे मुझे I have to be at 0 degrees, and after 1 second I have to be at 3.14 radians. And there is no, and initially my velocity can be 0, should be 0, and finally my velocity should also be 0. So now you just pick up that. So 1, T0 is 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 2, 3. So that's what you get here. And the unknowns are, we have to find them. So we have already grouped them in one vector. And the right side is, initially we were at 0 radians, 0 velocity initially. Finally, we have to reach pi radians. So this will be pi or 3.14. And final velocity will be 0. So this vector is 0. So now we just do this, take the inverse of this. And the inverse of this is the, you already know how to invert a matrix. You just take the, you find the determinant of it. And 1 over determinant multiplied by the adjoint of that matrix will give you the inverse of that. So if you find the determinant of this, we already found the determinant of this here, which is Tf minus T naught raised to power 4. This is the determinant, which is non-zero, which means the inverse does exist. Okay. If the determinant is not 0, in this case determinant is 1, because Tf is 1 and Ti is 0. 1 minus 0 is 1 to the power 4, so it is 1. Okay. And now we have got, so this is your trajectory. What is the equation of this plot? Plug in the A's values. From here, I found that A naught is Qi, Qi is 0, so A naught is 0. So this will not be present. Okay, iski jagah 0 डाल. A1 is 3 pi, so put 3 pi here. Okay, 3 pi. नहीं, sorry, A1 is 0, इसकी जगह भी A0 आ जाएगा. A2 की जगह उसकी वैल्यू डाल दें 3 pi, 3 pi t squared. और A3 की जगह इधर डाल दें -2 pi. So ultimately, this trajectory, the equation of this looks like this. Q of t is -2 pi t cube plus 3 pi t squared. Okay? It's a cubic function. So that's why you see it, the arcs here, and you see it very small. So this is the trajectory in order to achieve this motion. Now, how will you use it? Let's say you want the robot to, you want to find the position at time t is equal to 0.2 seconds. So just plug in 0.2 here for t, do the multiplication and summation, and you will get the corresponding position, which is almost like point, if you look here, it might be 0.2 or something in radians, or 0.2 to 0.3. Okay, let's say someone wants you that where you should be at t is equal to 1. So at t is equal to 1, we know that at final time we should be at pi. So just confirm it. So -2 pi into 1, it will be -2 pi, plus 3 pi into 1, it will be plus 3 pi, -2 pi plus 3 pi is pi radians. So this is correct. How about the velocity plot? Because we said trajectory is not only about positions, it's also about finding velocities and accelerations. So velocities plot, now you have the coefficients. You have found the values of the coefficients. You just plug them in now here. So A3 is -2 pi, so this will be -6 t squared. Yeah, -6 t squared. And A2 is 3 pi, so this will be 6 t. And this is the plot of this. Okay. And finally, the acceleration plot, you just plug in the acceleration coefficients in here. And you get this, which is a straight line. And I can tell that it's a straight line because it was not a quadratic function, it was just a straight line function. This is y is equal to mx plus c. So this is your y-intercept, and this is your slope, and this is your y. So this is a straight line. So now the problem is, you started from here, 20 radians. You started with extremely high acceleration because you have to reach somewhere in a very short amount of time. and then you were supposed to stop there. Okay. Okay. So in order to stop there, you had to decelerate by the same amount that you accelerated. Okay. So at the final time one, this is what your acceleration is, and you have to make a certain stop. Why? Because your final velocity has to be 0. Okay. So this is any question so far. So this is how called planning or trajectory training, a trajectory generation. And now the trajectory that we have generated is called a cubic trajectory. Can anyone tell me what is this maximum velocity? What is the value of this maximum velocity? I can see here from that it's 4.6 something, but how to find it mathematically? Hello? Anyone can find a maximum of an arc? Can anyone find a maximum of an arc? जी आवाज कट रही है आप चैट में लिख दें whoever wants to answer. सादात खान आपकी आवाज कट रही है जी हमें we cannot hear you, so please write it down in the chat window.
Sir, put t is equal to 0.05 in the velocity equation.
Yeah, but that's what you can. That's one way to do it. But how did you know? If this plot was not there, how would you know that the peak occurs at 0.5?
Sir, take the derivative and equal that derivative to 0.
Equate that derivative to 0. Perfect. And you will find the peak velocity. So now you see that what purpose these equations serve. You can find what should be the maximum velocity of the joint in order to achieve this motion. Okay. So now this is exactly how this motion was generated in the previous example. How this similarly you may be asked to do this one. Just the qi is changing. Look, qi is 112 degrees, qf is this, and initial velocity, let's say it's 0, final velocity is 0. So just the a's coefficient will be different for this one. For this one, the initial qi and the final qf are different. So again, it will have its own a's coefficients. That's the only difference between the two trajectories, the coefficients of a. Otherwise, this is also cubic polynomial. This is also cubic. Everything is cubic. Okay? So that is how you plan the trajectory. But the problem is, if you saw here, I could not look. Let's say I want the motion to be even more smoother. I want to accept constraints on acceleration as well. I want to guarantee that I can achieve a certain desired acceleration at the TF and certain desired acceleration. In order to satisfy those 6 constraints, my polynomial degree has to go 1 level or 2 levels up. So now instead of a quintic polynomial, which was good for 4 constraints, okay, 4 constraints mean 4 coefficients were unknown. Now, if you are giving me 6 constraints, I have to have a quintic polynomial. And now there will be 6 coefficients that are unknown. Okay. So just like we did on the previous slide, take this equation and put t is equal to 0 at t naught, ti, and just repeat the same. And this time you will have a 6 by 6 matrix here, a 6 by 1 matrix of unknown coefficients here, and a 6 by 1 known values on the right here. And you can solve them and you can get that. And the example of this is, let's say t naught was 0, tf up to 2 seconds Initially, I was at 0 degrees, but after 2 seconds, you want me to be at 20 degrees. Wait a second, ये 20 नहीं है, ये 40 है. So I think plot में किसी और के लाया हूँ equation के, और यहाँ पे ये 40 degrees है. So we'll plot them in the lab, so फिर ये ठीक हो जाएगा. वरना apparently यहाँ पे भी mistake है कि ये या तो ये भी 40 कर लें, क्योंकि ये 40 के मुताबिक हुआ है ना. तो अगर इसको हम 40 करते हैं तो फिर let's verify. जब 40 करेंगे QF, so we'll put it in this. Okay, so T is 0, 0, 0, 0, 0, and naught will be equal to this. तो इससे तो पता नहीं चला. QF कब करते हैं इसमें? QF T is equal to TF. So TF is 2. So this will be 2A5, no, 2 to the cube, 2 to the 5, 32A5. So that's why you see 32 here. Okay. And right side पे 20 है. अच्छा 14 नहीं है. तो इसका मतलब है कि ये plot इसका नहीं है. We have to find it. तो ये lab में हम verify कर लेंगे. Just don't take this plot as correct, because I clearly see that the final is 40 here after 2 seconds. और यहाँ पे हम कह रहे हैं कि final should be 20. ठीक है. तो ये lab में हम कर लेंगे. ठीक है. So I'll regenerate these plots. But this is how, and this is, we'll do this next time. Linear segments with parabolic blends. It's another way of generating joint space trajectories. Today, we generated a trajectory using the polynomial method. And we were planning point-to-point motion because we were only interested that what was the initial point and the final point, and what were the initial velocities and the final point. Okay. If you don't have question, then I'll just quickly do this, correct these calculations. So we got this. Okay. So let's say this is my matrix. So A's will be 1 0 0 0 0 0 0 1 0 0 0 0 0 0 2 0 0 0 1 2 4 8 16 32 0 1 4 12 32 80 and 0 0 2 12 48 160. So let's say this is my A matrix, capital A matrix. Okay, and let's evaluate it. So it's giving me, this is my A, and if I find the determinant of this A, then it is this 2 into 2.04 into 10 raised to the power 3. Okay. Okay, and B was, the right side was 0 0 0 20 0 0. Okay, and I want to find A. So A is this formula in MATLAB. So this was my B. And in order to find A, just do this. So A, which you get here it is 0, A1 is 0, A2 is 0, A3 is 50, A4 is हाँ, इसका मतलब है ये भी टाइपो है, तो हम क्या करेंगे, we will bring in इधर 40 ले आएंगे. Now I think it will be good. ठीक है. Now look, A is 50. A is 50. A3 is 50. A4 is minus this 7.5. ठीक है. अब अगर इसको आप प्लॉट करेंगे तो प्लॉट के लिए we have t axis जनरेट कर लेंगे. जीरो से लेके लेट्स से 20 में गैप हम 0.01 रख रहे हैं. 2 था, 2 ही था ना, 2. हाँ जी 2. तो अब हमारे पास जो पॉलिनोमियल है पोजीशन का, it will be q will be a of 5, a में से 5 वैल्यू उठा लें मल्टीप्लाइड बाय t 5 प्लस a के फोर्थ कोएफिशिएंट उठा लें मल्टीप्लाइड बाय दिस थर्ड कोएफिशिएंट उठा लें वेक्टर में से मल्टीप्लाइड बाय दिस, सॉरी फोर्थ कोएफिशिएंट उठा लें, ऐसा नहीं, सेकंड p स्क्वायर, आखिरी 1, अच्छा ए का साइज 6 है, सॉरी 6, 5, 4, 3, 2 और 1. ठीक है. तो नाउ यू विल गेट योर क्यू इज देयर. अच्छा इस पे इतराज है इसको, A6 इस तरह उठाते हैं, सॉरी हाँ जी, ये ब्रैकेट नहीं रहता, स्मॉल ब्रैकेट. Now you find your this. तो Q के undefined T, अच्छा T को भी वैलिडेट करना. Now you get these many Qs. ठीक है. If we plot it now, plot against T, Q को plot करें, so और grid को भी on करें, so now you got this, which is from 0 to 40. Okay, so the only mistake in the lecture was it should be 40. It should be 40. Sorry about that. ये हटा दें और ये हटा, और इसकी जगह क्या ले आए, 40, क्योंकि कैलकुलेशन 40 के लिए हुई है. ठीक है. तो ये 40 हो जाएगा और ये नीचे वाला भी 40 होगा. Now your slide is correct. लेकिन सबर करें जरा, इसमें अभी भी ये आखिरी प्लॉट ठीक नहीं है, लेकिन ठीक है आखिरी प्लॉट को हम इंशाल्लाह लैब में ठीक कर लेंगे. आई प्लॉटेड पोजीशन और बल्कि लैब में क्या, ये अभी देखें ना, ये अभी आपका लैब है, बस आप उस दिन कर लेंगे, मैं भी इसको रेडी कर दूँ. Q dot will be 5A5, 5 multiplied by A5, हम उसको A6 इसलिए कह रहे हैं कि यहाँ नंबरिंग 1 से स्टार्ट, and T raised to power 4 plus 4 into A4 multiplied by T raised to power 3 and ठीक है, plus 3 multiplied by A3 multiplied by T to the square plus 2A2T, 2A2T, and last one will be A1. और इसको भी प्लॉट करें तो you will get the second plot, अगर कहीं गलती नहीं की. Okay, so we are almost done. Just a thought आ जाए. Yeah, it is this, which is in the lecture notes. It's here. So this is correct. Third वाला correct नहीं था, इसलिए मैंने इसको cross किया. Now we are already doing it. Let's do the third one as well. Third one is Q double dot 20 multiplied by A5 multiplied by T to the 3 plus 12 multiplied by A5 multiplied by T to the squared plus 9 multiplied by A3 multiplied by T plus 2A2, 2 multiplied by A2. Plot T Q double dot. So now this will give you the acceleration plot, which is here. That was the only mistake. ठीक है, ये गलती से मैंने इधर दोनों प्लॉट सेम पेस्ट कर दिए थे इस स्लाइड में. ये 2017 की बात, कनाडा में. So I crossed it and now it should be replaced by this. So I'll do correction, but now look at the acceleration plot. It's very smooth. तो आपके acceleration भी बड़े smoothly change हो रहे हैं. जब acceleration smoothly change नहीं हो रहे होते, आपको धक्का लगता है, jerk लगता है. रोबोट का jerk आपको feel भी होगा. तो अगर आप चाहते हैं कि आपके acceleration smooth रहें, ठीक है, तो क्विंटिक पॉलिनोमियल यूज करें. तो आपके एक्सेलरेशन का प्लॉट भी क्यूबिक होगा. क्यूबिक कर्व होता है, स्ट्रेट लाइन नहीं होता. दिस इज क्यूबिक. ठीक है. सो और आखिरी एक्सेलरेशन वाज नॉट गिवन. अच्छा, अब इसमें ये एक चीज है, इसको एक्सप्लोर करना है कि भाई फाइनल पे 2 सेकंड के बाद एक्सेलरेशन को 0 होना था. ये तो एक कंस्ट्रेंट वाज गिवन ना, तो ये 0 क्यों नहीं है. तो आई विल एक्सप्लोर दैट कि इसमें और क्या गड़बड़ रह गई है कि भाई इधर इसको 0 होना है up to 2 seconds. Up to 2 seconds we should get the final acceleration to be 0, but here it doesn't seem to be 0. So I'll figure that out and I'll discuss it in the next class. Okay, any questions so far? अगर ये चीज समझते हैं तो इसका मतलब है कि बस इंजीनियरिंग के लिए रेडी हो गए. अगर नहीं समझते तो बस